So, in the last class, we have seen how to write a difference table, that is a diagonal difference table. Now, in this class, we can see how the error propagates in a difference table. That is, if an error occurs in any y value corresponding to a particular x value, what happens when we write the difference table. For that, we can consider certain y values. Suppose the y values, as usual, we will be uh, writing them as y0, y1, then y2, y3, y4, y4, y5, y6, y7, etc. Now, suppose an error occurs in this particular value. A small error, epsilon, happens in this y value. Now, when we write delta y, we know that delta y is the difference between two consecutive y values. Now, delta y0, as you know, will be equal to delta y0 is equal to y1 minus y0. Then delta y1 is equal to y2 minus y1. Then comes delta y2, then delta y3, and delta y4 is actually y5 plus epsilon minus y4 here. So here we have taken the difference between y4 and y3. So in the next step, we have to take the difference between y5 plus epsilon and y4. That is, we are getting y5 plus epsilon minus y4. That is equal to y5 minus y4 plus epsilon. And this is delta y4. So this is next step. We will be getting delta y4 plus epsilon. So here comes delta y4 plus epsilon. And again, next differences between y6 minus y5 plus epsilon. So when we take the difference, this becomes equal to y6 minus y5 minus epsilon, or this is equal to delta y5 minus epsilon. So here comes delta y5 minus epsilon. Then next is y7 minus y6, and that is equal to delta y6. Then we can write the second differences. Second difference is usually represented as del square y. So when we write the del square y values, we can see that the first one is del y1 minus del y0, that is del square y0. Then comes del square y1, then del square y2, and then comes del y4 plus epsilon minus del y3, that is equal to actually del square y3 plus epsilon. And the next difference is del y5 minus epsilon minus del y4 minus epsilon. So that becomes del y5 minus del y4 minus 2 epsilon, or that is del square y4 minus 2 epsilon. Then next is del y6 minus del y5 minus epsilon, or that is equal to del square y5, then del square y5 plus epsilon. So in this manner, we can complete the entire higher order differences. As you see, the difference, the error actually it spreads as the order of difference increases. And it is actually spreading fanways. You see this? The actual error occurred in the Wi-Fi values and it spreads out like this. So, as the order of the difference increases, the error also increases. And we can see that in the error in the first differences, that is del y values, the coefficients are +1 and -1. This is similar to the binomial coefficients of the binomial expansion of 1 minus epsilon raised to r. For this, we will be writing the coefficients. We can easily determine the coefficients like this: 1 1 1. This triangle gives the coefficients in the binomial expansion, and here the first order we are getting 1 minus epsilon raised to 1, that is the coefficients are 1 and -1. And in the next column we can see that the coefficients of epsilon are +1, -2 and +1. It is 1, -2 and 1, -2 and +1. And for the next one, 1, -3, +3, -1, +1, -4, +6, -4, +1, -5, +5, minus, minus. So the coefficients of the error epsilon are similar to the coefficients of the binomial expansion of 1 minus epsilon raised to r. And another important property is that in any column, the sum of the errors will be, algebraic sum of the errors will be 0. That is here plus epsilon plus minus epsilon, that is 0. Here also 2 epsilon minus 2 epsilon 0. Here 4 epsilon minus 4 epsilon 0. And in this column also, sorry, here I haven't written the entire, that is del raised to, next del raised to 4 by 4 plus 4 epsilon, sorry, minus 4 epsilon. And the next one will be del raised to 4, this is y4, this is y5 plus epsilon. Okay. So here also you can see that 6 plus 1 7 plus 1 8 minus 8 0. So algebraic sum of the errors in the table will also be equal to 0. So these are the main properties of, or these are the consequences when an error occurs in a particular y value. So the first one is that the error spreads out in a fanways manner. In a fanways manner with the center at the erroneous y value. Then as the order of the differences increases, the error also increases, and the algebraic sum of the errors in any column will be equal to 0. So this much today, and in the next class we will be deriving Newton's interpolation formula. Okay, thank you.